This is pre-AP pre-calculus. We're continuing section 9.3, so it's part 2. We just concluded the derivation of the unit circle. We learned earlier that in a right triangle, the definition of sine, cosine, and tangent. Sine of theta is opposite leg over hypotenuse. Cosine of theta is adjacent leg over hypotenuse, and tangent of theta is the opposite leg over adjacent leg. That's old news. If you look at this picture that I have over here, I'm going to make this just a little bit bigger so I can see it a little bit better. So we have a circle coming over here and we draw this angle. Let's say this is theta. If it is a circle whose center is at the origin, we got the radius. This height is going to be the y value, and this is going to be the x value. So that makes this ordered pair. We went to the right x, we went up y. That's not revolutionary. But I'll tell you what is. The angles that we're going to use every time is going to be the reference angle. Opposite the reference angle will always be y. So sine of theta will always be y, and then over top of the hypotenuse will always be opposite 90. That's always going to be r. So if you have a circle at the origin and you draw an angle, sine of theta will always be y over r. Similarly, cosine of theta will always be the adjacent leg over hypotenuse. The adjacent leg will always be x. Tangent, opposite leg will always be y, adjacent leg will always be x. Now, if you're thinking, well, that doesn't apply all the time, it does. Let me show you a different quadrant. So let's say that we had, let's just go in quadrant 3. Terminal side falls in quadrant 3. This is what theta is. If you want to find the coordinates of this point, this would be like theta prime. Opposite of theta prime is y. Adjacent leg, opposite leg of theta prime is y. Adjacent leg of theta prime is x, and the hypotenuse is still r. Any way you cook it, if using a reference angle, which we're going to always use a reference angle, the opposite leg is always y, adjacent leg is always x, and the hypotenuse is always r. If you remember that sine and cosecant are reciprocals, cosine and secant are reciprocals, tangent and cotangent are reciprocals. If we want to take it a step further, and we do, I can even make this more basic. If you're referring to a unit circle where the radius is 1, if you take y and divide it by r, and r is 1, that's going to always just give you y. Cosine of theta is x over r, that's x divided by 1, that's going to be x. If you have a true unit circle where the radius is 1, we can think of sine as just y, and we can think of cosine as just x. Allow me to illustrate. Let's just take the unit circle that we just learned. I'm suggesting that the x value is always cosine of theta and the y value is always sine of theta in a unit circle. I can show this to you. If you were to put in your calculator cosine of pi over 6, it's going to give you a decimal that's equivalent to square root of 3 over 2. Sine of pi over 6 is going to be 1/2. Cosine of pi over 4 is square root of 2 over 2. And sine of pi over 4 is square root of 2 over 2. That's how this unit circle works. Let's see if we can check out some examples. Before we do some examples, I think we would want to have a reference in quadrant 1 of the unit circle. Now, if you have all this just flat out memorized, you probably don't need this. If you don't, you might need this. At pi over 6, our ordered pair is square root of 3 over 2, a half. At pi over 3, it's 1/2 square root of 3 over 2. At pi over 4, it's square root of 2 over 2 and square root of 2 over 2. Let me show you how that is very valuable. Using the coordinates on the unit circle, find the exact value of each of the following trig expressions. You're not going to have reference to a unit circle. This has got to come from your brain, or you have to draw a unit circle each time. Sine of 3 pi over 4 has a reference angle, theta prime, of pi over 4. Pi over 4, which is right here, if you had this right triangle, sine is y over r. And we are saying, in a unit circle, that's just y. What is the y value at pi over 4? It's square root of 2 over 2. If we go to this second problem, cosine of 3 pi over 4 and sine of 7 pi over 4, in both cases, the reference angle is pi over 4. So we're using the same triangle that we just used, but the signs of our answers might change depending on the quadrant you're in. For example, cosine of 3 pi over 4, according to this, cosine is the x value, so it's going to be x over r. This is going to be y over r, and in both cases, the r's are 1, so it's just x plus y. What is the x value at pi over 4? It's square root of 2 over 2. And this is not entirely correct yet, so wait for it. What's the y value of pi over 4? That's square root of 2 over 2. And here's the part you got to be careful of. What quadrant is 3 pi over 4? That's quadrant 2. What quadrant is 7 pi over 4? That's quadrant 4. In quadrant 2, is x positive or negative? It's negative. We're going to the left. In quadrant 4, is sine positive or negative? It's negative because we're going down. Now, you don't have to show this work, and you don't have to show this work. I'm just trying to explain all this to you. If we combine like terms, we're going to get negative 2 square roots of 2 over 2, and that reduces to negative square root of 2. If you don't like using the reference triangles in quadrant 1, you have options. So let me just do some more work for this problem, then I'm going to erase it as we do this next one. So the problem that we just did, here's an alternate way to do your work. And I don't care what your work looks like. I care about this, but how you get to that point, I don't care. 3 pi over 4 is in quadrant 2. So you could draw it like this. Makes the reference angle pi over 4. We have to go left, square root of 2 over 2. We have to go up, square root of 2 over 2, and the radius is 1. So what is cosine of 3 pi over 4? It's negative square root of 2 over 2. 7 pi over 4 is in quadrant 4. That makes the reference angle pi over 4. Let me write that in a different spot. That makes this square root of 2 over 2, negative square root of 2 over 2. This is the angle 7 pi over 4. So sine of 7 pi over 4 is negative square root of 2 over 2, which is where we're getting this from. I don't care how you show your work. You just got to do it correctly. Tangent of pi over 6. If we go back to this little fellow that I drew up here, pi over 6, y is a half, and x is square root of 3 over 2. Tangent is y over x. So that means we're going to have 1/2 over square root of 3 over 2. let's not leave this as disgusting as this looks. Let's rationalize. Actually, first let's make it not complex. I'm going to multiply this by 1 in the form of 2 over 2. What does that do for me? Well, it cancels those 2's and those 2's, and now we have 1 over the square root of 3. Some cases we could leave it that way, but I would rather not. Let's rationalize our denominator. Let's multiply by 1 again, and this time in the form of square root of 3 over square root of 3. It's going to give us square root of 3 over 3. This is what tangent of pi over 6 is, which is equivalent of saying what's tangent of 30 degrees? It's square root of 3 over 3. Now the next one, tangent of 7 pi over 6, this reference angle is pi over 6. So that means the absolute value of this answer from our previous problem is going to be the same absolute value as this answer. The sign could change depending on which quadrant you're in. 7 pi over 6 is in quadrant 3. In quadrant 3, both the y and x are negative. So technically speaking, that's going to make this negative 1/2 over negative square root of 3 over 2. If you divide two negatives, you get a positive. We already know that this simplifies to square root of 3 over 3. If you don't like that, then what you do is you draw an angle in quadrant 3. I shouldn't say that. You draw an angle in standard position where the terminal side terminates in quadrant 3. It's going to make the reference angle pi over 6. Opposite pi over 6 is going to be negative 1/2. Adjacent to pi over 6 is negative square root of 3 over negative 2, and the radius is 1. If you continue from there, you're going to get square root of 3 over 3. Next, we have secant of 11 pi over 6. 11 pi over 6 has the same reference angle of pi over 6, just in quadrant 4. Secant is the reciprocal of cosine, so it's r over x. We're saying that r is the radius and x is the adjacent leg. I'll just draw a picture of this. Now I could just go up here and just grab square root of 3 over 2 and reciprocate it. If I do, I'm going to get 2 over the square root of 3. If I rationalize that, that's going to change some. If it doesn't make sense, you do that, and then if you draw this picture, this reference angle is pi over 6. This is a right triangle. Opposite of pi over 6 is negative 1/2 because we went down. The adjacent is square root of 3 over 2. It's positive, we went right, and the radius is 1. Knowing that cosine is square root of 3 over 2 and secant is reciprocal, we get 2 over the square root of 3. If you rationalize this by multiplying by 1 in the form of square root of 3 over 3, you're going to get 2 square roots of 3 over 3. Next, we have cosecant of 4 pi over 2 plus tangent of 5 pi over 4. First of all, cosecant of 4 pi over 2 reduces to 2 pi. 2 pi is on the positive x-axis. In this location, there's no special right triangle. In fact, there's no triangle at all. In a unit circle, that's going to make x 1, y is going to be 0, and r is going to be 1. Sine of 2 pi is 0. Cosecant's the reciprocal of 0 is 1 over 0, which is undefined. Tangent of 5 pi over 4, this has a reference angle of pi over 4. Let's examine that for a second. Pi over 4. Tangent is y over x. If you divide square root of 2 over 2 by itself, it's going to reduce to 1 every time. 5 pi over 4 is in quadrant 3. That makes y and x both negative. So I'm just going to show more work than I need to. That's going to reduce to 1. Undefined plus 1, well, that's undefined. Sine of negative 2 pi over 3. That's going to put us in quadrant 3. In quadrant 3, sine is negative. The reference angle for this is going to be pi over 3. If you go up to our picture that we drew up here, pi over 3, the y value is square root of 3 over 2. And we're saying it's in quadrant 3, so it's negative square root of 3 over 2. Easy peasy. Tangent of negative 5 pi over 2. This is a quadrantal angle. Allow me to show you. If we start here at 0 pi over 2, we go around a negative revolution, it's negative 4 pi over 2. Halfway around would be negative 2 pi over 2. So this would be negative 1 pi over 2, negative 3 pi over 2, negative 4 pi over 2, negative 5 pi over 2. So that's right here on the negative y-axis. Just going to get rid of some of this here. So the x value here is 0, the y value is negative 1, and the r value is positive 1. I really drew that in a terrible spot. Tangent is y over x, so that's negative 1 over 0, which is undefined. Tangent of negative 7 pi over, tangent of negative 5 pi over 2 is undefined. Next, this is another quadrantal angle. So if we start, this is at 0 pi, 1 pi, 2 pi, 3 pi, those are all negatives. I forgot to say negatives. I'll do that again. 0, negative 1 pi, negative 2 pi, negative 3 pi. At negative 3 pi, we have to know it's quadrantal what the x, y, and r values are. X is negative 1, y is 0, and r is 1. Cosine is the x value, so that's negative 1, plus. Then we have cotangent of negative pi over 4. Now, negative pi over 4 has a reference angle of pi over 4. Cotangent is x over y, so that's square root of 2 over 2 divided by square root of 2 over 2, kind of. We are in quadrant 4. In quadrant 4, let me draw this real quick. In quadrant 4, x is positive and y is negative. And we're saying those have the same value of square root of 2 over 2. If you divide something by itself, you get 1. In this case, you're dividing things with opposite signs, so it's negative 1. This becomes 2 plus a negative 1, which I like to call 1. Last page. Positive and negative quadrants. I think this is pretty important. I think you would agree that in quadrant 1, the x values are positive and the y values are also positive. And we are saying that an ordered pair is cosine of theta followed by sine of theta. Our conclusion from that is in quadrant 1, all of the trig functions are going to be positive. Cosine's positive, sine's positive, tangent is sine over cosine. If you divide two positives, you get a positive. If you go to quadrant 2, you got negative, positive. So we're saying that cosine of theta is negative and sine of theta is positive. So in quadrant 2, Cosine's negative, as we just saw. So would tangent, because tangent sine over cosine. Positive over negative is a negative. So the only thing that's positive in quadrant 2 is cosine. Now when is sine. When I say the only thing, its reciprocal is as well. So sine and cosecant. Right now we're talking about sine, cosine, and tangent. The reciprocal trig functions will have the same SIGN sign. In quadrant 3, the x and y's are negative, so cosine is negative, and so is sine. But if you divide sine by cosine, which is what tangent is, which I guess I didn't really make that clear yet. Let me make that clear. Tangent of theta is y over x. Guess what y is? Sine. Guess what x is? Cosine. I think I mentioned that earlier, but didn't make it clear why that was true, and I apologize. Tangent of theta is the same thing as sine over cosine. That's important. In quadrant 3, therefore, tangent is the only trig function of the top 3 that's positive. Its reciprocal cotangent would also be positive. In quadrant 4, we go right and we go down. That makes cosine of theta positive. It makes sine of theta negative. Cosine of the top 3, of the big 3, is the only one that's positive in quadrant 4. All right. Describe below are angles in standard position. Determine in which quadrant or on which axes each angle terminates. Give an explanation that clearly justifies your reasoning. If no angle exists, explain why. I am going to give you possibly TMI. Cosine of theta is equivalent to x over r. That's a fact. And we are saying that this is bigger than 0. The conclusion, then, since r is always 1, we are saying that cosine of theta is just x, and x is bigger than 0. If x is bigger than 0, it means x is positive. So when is x positive? It's positive to the right of the y-axis. So our conclusion, theta terminates, ends, what that means, right of the y-axis. We have tangent of theta, which is y over x, and that's less than 0. Y over x, if it's less than 0, it means either y or x is negative, but they both can't be negative, one or the other. When does that happen? That happens in quadrant 2 or 4. If I combine those two answers, I need theta to terminate to the right of the y-axis and be in quadrants 2 or 4. That only happens in quadrant 4. So our conclusion is theta terminates in quadrant 4. It means the terminal side of the angle is in quadrant 4. Let's check out B. Cosine of theta is bigger than 0. You know what? Maybe I should do, instead of doing cosine is x over r, maybe it's wiser if I just say cosine is equal to x. That's what I'm going to do. I have to change a bunch of keys, but yeah, let's do it. B, cosine of theta is bigger than 0. Well, look, we've already figured out what happens when that happens. If cosine of theta is equal to 0, and that's bigger than 0, it means theta terminates to the right of the y-axis. If tangent of theta is undefined, tangent y over x, the only way that's undefined is if x is 0. If x is 0, then the conclusion is that theta terminates on the y-axis. So we are saying that theta is to the right of the y-axis, and it's also on the y-axis. You can't be to the right of something and be on it at the same time. It's impossible. Our conclusion, theta does not exist. Example C. Tangent of theta is y over x. If that's bigger than 0, then the conclusion is either both x and y are positive, it's in quadrant 1, or both x and y are negative in quadrant 3. Our conclusion, theta terminates in quadrant 1 or 3. Cosecant of theta is the reciprocal of y in a unit circle, and it says that's less than 0. When is y less than 0? That's below the x-axis. If we combine the answers, below the x-axis in quadrants 1 or 3, got to be in quadrant 3. Cool. D. Sine of theta is less than 0. Sine of theta is equivalent to y. If that's less than 0, then theta must terminate below the x-axis. Secant of theta is the reciprocal of x. If that's undefined, that means that x is 0, and that happens on the y-axis. Therefore, theta must terminate on a y-axis. So where in the world could theta be if it's below the x-axis and it's on the y-axis? It must mean that theta terminates on the negative y-axis. Cool. Last problem. Suppose that theta is between pi over 2 and 3 pi over 2. And sine of theta is 1/2. What's the value of theta and the exact value of the other 5 trig ratios? Well, what does this tell us? This tells us that theta terminates to the left of the y-axis, because this is the positive y-axis and this is the negative y-axis, so it's someplace between them. We're also told that sine of theta is 1/2. If sine of theta is 1/2, that means theta is above the y-axis, because this is equal to y, and that's positive. If you combine those two facts, that tells us that theta terminates in quadrant 2. That's to the left of the y-axis, and it's above, I'm sorry, this should be above the x-axis. Y is positive above the x-axis. All right, so let's draw a picture. Quadrant 3. And what we know is the y value is positive 1/2. Well, what type of a special right triangle has the y value of 1/2? That's 30, 60, 90. So pi over 6, which is 30. Opposite that's 1/2. The adjacent leg is negative square root of 3 over 2, and the hypotenuse is 1. So what is sine of theta? It's 1/2. We knew that from the beginning, but the picture confirms that. What is cosine of theta? It's negative square root of 3 over 2. Tangent of theta is 1/2 divided by negative square root of 3 over 2, which we already worked out earlier. This simplifies to square root of 3 over 2. Once you get those three, to get the other three, cosecant is reciprocal of sine, so that's 2. Secant of theta is the reciprocal of cosine, that's 2 over negative square roots of 3. If you rationalize it, it's 2 square roots of 3 over negative 3. And cotangent is the reciprocal of tangent. That's going to end up being a negative square root of 3. Just to show you how that works, if I take 1 over, well, let me say it. If I take 2 over negative square root of 3, and I multiply the top and bottom by the square root of 3, hold on, did I make a mistake? I did, I'm sorry. This right here should be square root of 3 over 3. Thousand pardons. It's going to make this 3 square roots of 3 over negative 3. Those cancel, and we get negative square root of 3. That's why that's cotangent of theta. All right, well, that concludes that little fella. Do the homework, please.